July 1st, 2025, an ordinary night for NASA's Sky Survey team until something extraordinary appeared. The Atlas Survey telescope in Chile captured a faint, fast-moving object slicing across the southern sky, a cosmic visitor unlike any other. It was soon confirmed as SEDA 2025 N1 Atlas, the third interstellar object ever detected in human history. Like Oumuamua in 2017 and Borisov in 2019, this new arrival, later nicknamed Three Eyes Atlas, wasn't born in our solar system. It came from the direction of Sagittarius, a true wanderer from another star. At first, excitement rippled through the global astronomy community. The object's speed was astonishing, nearly 152,000 miles per hour, and its orbit was distinctly hyperbolic, proof that it was just passing through, never to return. Early models estimated its solid nucleus to be several kilometers wide, potentially 5 times the size of Borisov, with a mass of more than 30 billion tons. For scientists, this was a once-in-a-lifetime opportunity to study the raw material of another world, a fragment of cosmic history older than the sun itself. As 3i Atlas approached the inner solar system, it began to glow. Dust and vapor streamed off its surface, creating a shimmering coma that reflected sunlight in strange, uneven patterns. Spectrographs revealed unusual gases, water vapor, carbon dioxide, and complex organics, but in proportions that didn't match any known comet. Something about it was off. Some called it a frozen time capsule. Others whispered it could be artificial. NASA scientists dismissed those theories until the night everything changed. At 1:17 a.m. UTC, telemetry from the Jet Propulsion Laboratory suddenly spiked. Energy readings surged far beyond anything caused by sunlight or solar wind. Within minutes, the Atlas team's internal chat lit up with urgent alerts. Anomalous signature detected. Possible collision event. Then at 1:21, silence. All contact with 3i Atlas was lost. NASA's Deep Space Network, which tracks signals from spacecraft billions of miles away, went dark for nearly 20 minutes. Every attempt to reacquire data failed. It was as if the object had vanished. Inside JPL, engineers moved quickly, but their faces told the story. This was no routine glitch. Within the hour, NASA elevated the event to red alert, the highest internal level for space anomalies. The message that woke Dr. Elena Thorne, director of the Planetary Defense Coordination Office, was short but chilling. Unexplained impact, loss of contact. By 2 a.m., NASA had convened an emergency global conference call with the White House, the European Space Agency, and U.S. Strategic Command. Telemetry indicated a massive energy release, one that no natural outgassing could explain. Something had struck 3i Atlas. But what? Astrophysicist Dr. Marcus Voss ran high-resolution impact models to simulate what could have happened. His results painted 3 terrifying possibilities. In the first, a small but ultra-fast object, perhaps only a meter wide, slams into the comet at more than 100 kilometers per second, enough energy to shatter it into thousands of fragments. The second scenario was even worse, a larger impactor, 10 meters or more, vaporizes part of the nucleus completely, releasing energy comparable to millions of megatons of TNT, similar to the Shoemaker Levy 9 impacts that scarred Jupiter in 1994. But it was the third possibility that most alarmed NASA, a glancing blow. In this case, the object remains mostly intact, but its orbit shifts and fragments scatter unpredictably. Even a tiny change in velocity, just a few dozen meters per second, could send debris careening into entirely new trajectories, some possibly toward the inner planets. As data trickled in, supercomputers ran thousands of orbital simulations. Most fragments appeared to spread harmlessly along the comet's path, but a small percentage, less than 1 in 10,000, were projected to drift dangerously close to Earth's orbital corridor within weeks. Statistically, the risk was minimal. But as history had proven with the Chelyabinsk meteor, minimal didn't mean impossible. The situation was made worse by a hard truth: Earth's southern skies are poorly watched. NASA's main detection arrays, PAN, STAROS, and Atals, are optimized for the northern hemisphere. That means vast areas over the southern oceans and Antarctica remain nearly invisible to our surveillance network. If any fragment of Three Eyes Atlas approached from below the ecliptic, humanity might have only hours of warning. Inside NASA's control rooms, large screens flickered with risk maps and probability curves. Even a 0.1% chance of impact was enough to trigger new protocols. Thorne authorized the rapid activation of additional observatories in South Africa and Australia. Amateur astronomers across the globe were called to action, turning their telescopes into part of a worldwide defense net. Citizen scientists began uploading images, helping track faint streaks of light across the night sky. Meanwhile, behind closed doors, the classified emergency call continued. The White House liaison pressed for impact probabilities and mitigation plans. Military observers demanded a threat matrix. How large were the fragments? Could they hit satellites or power grids? Dr. Thorne pushed for calm, emphasizing that no confirmed debris was yet on course for Earth. Still, the room knew what the level 4 hazard classification meant: potential for planetary consequences. The debate grew tense over whether to alert the public or keep details restricted until orbits were confirmed. Some feared that disclosure could trigger panic. Others warned that secrecy could cost lives if even one fragment slipped through undetected. In the end, NASA issued only a short statement describing an anomaly involving an interstellar object under ongoing analysis. The rest remained classified. By dawn, the Planetary Defense Coordination Office had mobilized every available resource. Mission planner Dr. Isaac Feldman led the Southern Net initiative, patching the surveillance gap with emergency telescope time and AI-assisted data analysis. The European Space Agency contributed tracking from La Silla and Paranal, while Japan's Subaru telescope joined the effort. Even private companies volunteered satellite assets to monitor debris clouds. At the same time, engineers rushed to ready Comet Interceptor 2, a next-generation space spacecraft designed to launch from Earth's L2 point and intercept unpredictable targets on short notice. The plan was bold. If any sizable fragment was confirmed to be inbound, the probe could be dispatched to strike or deflect it. A maneuver built on lessons from NASA's DART mission. But the timelines were brutal. For large fragments, warning might be a week. For smaller ones, just hours. Across social media, amateur astronomers noticed the blackout and began sharing raw telescope images. Some claimed to see unusual streaks near the predicted path of Three Eyes Atlas. Were they new fragments or just noise? NASA refused to comment. Online forums exploded with speculation, from micro impacts to alien probes. Amid the noise, one truth remained: something real had happened, and the silence that followed was unprecedented. In the weeks that followed, the mystery deepened. Observatories gradually reacquired faint debris clouds where Three Eyes Atlas once was. The main nucleus appeared shattered, its fragments dimming as they drifted outward. No major impacts were detected on Earth, but that didn't ease the unease. If this collision had happened farther out, humanity might never have known until it was too late. The final NASA report, released quietly months later, confirmed the basics Three Eyes Atlas was discovered on July 1st, 2025. It was the third known interstellar object. A sudden energy spike and subsequent loss of telemetry indicated a violent fragmentation event. The cause still unconfirmed. the probability of debris entering Earth's orbit, officially listed as low but non-zero. Beyond that, the details remained classified. Today, the event stands as both a milestone and a warning. It proved that our solar system is not a closed, peaceful realm, but a crossroads where objects from other stars can appear without warning, carrying mysteries or perhaps dangers from beyond our reach. The blackout that silenced NASA that night was not just a technical failure. It was a reminder of how fragile our awareness really is, how much of the sky still hides in darkness. As we improve our telescopes and AI tracking networks, one question lingers. When the next interstellar object arrives, will we see it coming, or will it see us first?